Welcome to one of the world's largest titanium processing facilities, where raw earth is transformed into one of the strongest metals known to science. From above, the scale becomes clear. Every building here is dedicated to a specific stage of the titanium refining process.
Let's head inside and explore how this billion-dollar metal begins its journey.
These are the final forms titanium can take. Today, we'll witness how each form is manufactured step by step.
Titanium's story starts miles away in ore mines, where ilmenite and rutile are extracted from deep beneath the earth.
Loaded trucks travel long distances to feed the factory's demand for raw material. At the receiving dock, powerful hydraulic systems unload raw ore into the facility's first processing stage.
Before the ore enters the line, inspectors verify its titanium concentration and contamination levels.
Massive crushers break the ore into smaller fragments, preparing it for further refinement. Next, powerful mills grind the ore into fine powder, increasing surface area for chemical treatment. Magnetic separators remove unwanted metals, isolating the titanium-rich material. Gravity concentrators separate heavier titanium minerals from lighter waste material. Gravity concentrators separate heavier titanium minerals from lighter waste material. The purified concentrate is now pre-treated and readied for conversion into titanium slag. In massive furnaces, the concentrate melts into titanium slag, one of the core steps in purification. Once formed, the molten slag is carefully cooled to stabilize its structure. The cooled slag blocks are crushed once again to prepare them for chlorination.
Here, the chlorination chamber is prepared. The next step transforms slag into titanium tetrachloride.
Inside these reactors, slag reacts with chlorine to produce titanium tetrachloride, a crucial intermediate. The vapor then enters cooling towers where it condenses into liquid TiCl, ready for purification. This is the holding bay where unrefined titanium tetrachloride is stored before further refinement. Titanium tetrachloride now enters purification towers, where fractional distillation removes unstable contaminants. Advanced filtration systems eliminate remaining particles to achieve the purity required for metal production.
Technicians prepare magnesium reducers and purified TiCl, key elements for the Kroll process.
Here inside the reduction hall, TiCl reacts with magnesium under extreme temperatures to create raw titanium. After hours of chemical reaction, the reactors undergo strict cooling to stabilize the newly formed titanium. Once cooled, technicians open the reactor, exposing the fragile titanium sponge material.
Robotic cranes carefully remove the sponge, ensuring none of the brittle material is damaged. Large pieces are crushed into smaller fragments to prepare them for purification. Vacuum distillation removes excess magnesium, leaving behind a highly purified titanium sponge. Technicians classify the sponge by size and purity before melting operations begin.
The sponge is now transported to the melting area, where it begins transforming into solid titanium ingots.
Inside vacuum arc furnaces, the sponge melts into pure liquid titanium under intense electric energy.
The molten metal travels into reinforced molds, forming the first stage of titanium ingots. Controlled airflow ensures each ingot cools evenly, preventing metal fractures.
Once cooled, the ingots are extracted and moved toward alloying and shaping areas. Here, alloy engineers combine titanium with strengthening elements to produce specialized alloys.
Next, red-hot titanium enters powerful forging presses that mold the alloy into desired forms.
Rolling mills stretch and compress titanium slabs into thin sheets used across many industries.
Advanced shaping systems form titanium rods, cooling them rapidly to maintain structural integrity.
In the machining zone, CNC systems carve titanium into high-precision parts used in aerospace, medical, and industrial applications.
Automated drilling units now shape the titanium plates with extreme accuracy, ensuring perfect symmetry.
Multi-axis mills carve complex curves and structural profiles needed for aerospace and engineering components.
Turning lathes refine cylindrical parts, delivering ultra-smooth, dimensionally consistent surfaces.
Every component undergoes careful deburring to eliminate sharp edges and ensure user safety.
Before heat treatment, technicians prepare each piece for thermal stabilization. Before heat treatment, technicians prepare each piece for thermal stabilization. Inside these furnaces, titanium is heated to strengthen its internal structure. Rapid cooling locks in the material's improved strength and durability.
Final machining ensures each piece meets strict engineering standards, down to the micron.
Grinding machines flatter and refine the surface texture for uniform thickness. Shot blasting removes surface contamination and prepares titanium for polishing. Chemical baths remove microscopic residues and enhance corrosion resistance. Ultrasonic waves perform deep cleaning, reaching areas traditional methods cannot. Polishing machines now bring out titanium's natural shine and smoothness. Laser finishing modifies the surface at microscopic levels for high-performance use.
Laser finishing modifies the surface at microscopic levels for high-performance use.
Protective coatings shield the titanium from oxidation and extreme environments. Each coated piece passes through curing tunnels to solidify the protective layer.
In the inspection lab, experts check each piece for flaws invisible to the human eye.
In the inspection lab, experts check each piece for flaws invisible to the human eye.
X-ray machines ensure no internal cracks or structural weaknesses remain. Mechanical tests measure how much pressure titanium can withstand before deformation.
Laser measurement systems confirm that every dimension matches the exact engineering blueprint.
Laser measurement systems confirm that every dimension matches the exact engineering blueprint.
Laser marking permanently records the batch, grade, and tracking ID on every titanium piece.
Laser marking permanently records the batch, grade, and tracking ID on every titanium piece. Automated sorting systems categorize each titanium product for its specific industrial use.
Straightening rollers ensure each sheet has perfectly uniform and aligned edges. Hydraulic press machines apply immense pressure to create exact bends and industrial shapes.
CNC punching forms vent holes, mounting points, and technical patterns with flawless accuracy.
Assembled titanium components are prepared for aerospace, medical, and engineering applications. The micro-welding lab focuses on tiny components requiring microscopic accuracy.
The entire factory is monitored digitally to maintain real-time precision and efficiency. Final cleaning removes any remaining dust, residue, or fingerprints before packaging. A dry air process ensures no moisture remains, preventing oxidation. A protective film is applied to preserve surface quality during transportation.
Experienced technicians manually inspect every sheet to detect even the smallest surface flaws.
Thickness scanners confirm consistency across the entire sheet.
Precision weight checks ensure accuracy for shipping and structural use.
Barcodes and QR codes make every product fully traceable worldwide.
Bundles are strapped tightly to protect the titanium during handling.
Shrink wrapping provides additional moisture and dust protection.
Automated palletizers arrange the titanium bundles for efficient shipping. Finished titanium products are stored in temperature-controlled warehouses.
From here, titanium is shipped worldwide to factories, engineering firms, and aerospace industries. The titanium plates now enter the humidity-controlled drying chamber, where every sheet is stabilized for further precision work.
Industrial blowers ensure the titanium surfaces reach perfect dryness without warping.
A thermal equalization phase balances temperature across thousands of titanium sheets. Once fully dried, titanium sheets are transported to the precision grading section. Advanced sensors evaluate every sheet, assigning quality grades used for aerospace, medical, or industrial applications.
Titanium thickness is measured to micron-level accuracy, ensuring flawless consistency.
Laser scanners identify imperfections invisible to the human eye. Titanium is sorted into quality tiers before entering the cutting division. The precision cutting area shapes raw titanium into usable forms.
Computer-guided lasers cut titanium with extreme accuracy, forming components for high-strength applications.
Water jet cutting ensures zero heat damage, ideal for sensitive titanium components.
For thicker plates, rotary saws deliver powerful mechanical cuts.
Every cut component is cataloged and prepared for shaping. Titanium enters the shaping department, where heat-assisted forming begins. Controlled heating makes titanium flexible enough for shaping. Hydraulic presses mold titanium into engineered components. Rotary shaping wheels refine curves and structural bends.
Each piece is measured and calibrated to meet exact specifications.
Cooling ensures titanium retains its new structural form.
The shaped titanium pieces are now ready for polishing and finishing. The titanium now enters the polishing division, where raw strength transforms into precision beauty.
High-speed buffer wheels smooth the metal, preparing it for its final finish.
A micro-polish compound brings out the titanium's natural metallic sheen. Ultrasonic wet polishing creates an ultra-smooth, mirror-like finish. Warm air removes all moisture, leaving the titanium perfectly dry and ready for final inspection.
Every polished surface is examined under strict quality protocols.
Titanium's durability is tested with precision instruments. Proved titanium enters the packaging line.
The metal cools, stabilizing into its final form.
Automated wrapping protects the metal during transport. Titanium products are boxed, sealed, and prepared for shipment. Every package receives tracking labels for global distribution. The titanium is loaded for delivery to industries around the world. Packed and shipped, the titanium begins its journey to global markets.
From powerful engines to luxury goods, titanium's strength shapes the modern world.